Hi, my name is Liz Schlemer, and this is a video for IME 315 Financial Decision Making for Engineers. This particular video is on internal rate of return, which is one of the evaluation methods. So when we look at the 5 topics that are covered in this class, this particular video falls under investment analysis. There are generally 5 methods that are used in evaluation, and in another video I covered payback and net present value, and in this video I'm going to talk about internal rate of return. I'm not going to talk about in uniform annual benefit or cost or benefit cost ratio. So when we look at internal rate of return, or IRR, I'm going to look at 3 things: the calculation, the problem with multiple rates, and how we use the procedures we use for comparing alternatives using internal rate of return. So the calculation, what we're trying to figure out is determine the I, or the interest rate, such that the net present value is 0. And this will give you the answer to the question is, what is the return I'm getting on my cash, on this cash flow? So we have a given set of cash flow. It tells us what interest rate or return are you going to get. So sometimes people refer to this I star, such that the net present value is 0. This can be compared. It's a very useful thing because it can be compared to interest rates, other interest rates that you know, like savings rates or alternative investments in the stock market, or the cost of borrowing money. If oftentimes we compare this I star to a required return. So we say, well, if for this particular kind of investment with this level of risk, we expect X% return. And this return is often called MARR, or minimum attractive rate of return, and that's what we compare it to. If the return on a particular investment is greater than MARR, then we accept the project. But one of the tricky things is we can't compare just the interest rates of project and say which is the best project. We must use what's called incremental analysis, and I'll go through that in a little bit. So in order to calculate internal rate of return, we can sometimes, when it's a very short investment, we can, or only 2 cash flows, that we can actually use direct solution method and solve for I. And in this case, it's 9.6%. If we invest $1,000 now and get $3,000 in 12 years, that's a 9.6% return per year. Another way to do it is graphically. So we have a particular set of cash flows, and we can change the interest rate in the x-axis and calculate the net present value. And where the net present value is 0, or where the line crosses the x-axis, that particular interest rate is the internal rate of return. So this is where I star with internal rate of return, where the net present value is 0. We can also use Excel, so it's very simple. All we just do is type IRR equals for a range, equal IRR for a particular range, and it will return an interest rate, in this case 11.14%. Sometimes you have multiple rates, and in this case it's a little bit tricky to figure out which is the internal rate of return. For instance, this particular cash flow there above returns this line where we have the x-axis is the interest rate and the y is the net present value. You can see that the interest rate at which the net present value is 0, there's actually two places where the IRR is 0. It's around like 1%, and then 85 or 90%. And so the question is, which is the right one? And that's why in IRR they give you a guess value, because you want to have sort of an understanding that what is a kind of a reasonable rate of return. But there are ways to correct for this, but I think the main thing you need to know that this kind of problem occurs when there's more than one change of sign. So in this case, I have a negative 1,000, a positive 1,900, and then a negative 1,000. So there's a change of sign here and a change of sign here. That will give me multiple roots to this equation, and you could have problems determining what is the correct IRR. You just got to be careful of that. And then the last thing regarding internal rate of return is how you compare alternatives. So the problem with this is that you can have various alternatives. In this case, invest in a vending machine, invest in Apple stock, invest in a friend's startup, or do nothing. And the way that you would do it traditionally is calculate the net present value and choose the higher one. In this case, the net present value tells us that it's best to invest in a vending machine. But when we do a calculation for IRR, what ends up happening is we have an internal rate of return here that's 20%. So if we just chose the highest internal rate of return, we would say we would invest in Apple stock. And that's actually not the right answer. The right answer is investing in a vending machine. NPV is a thing that always gives you the right answer. But most companies like to calculate IRR, and you just need to be careful about when you're comparing alternatives that you don't go astray. So this is an example of how we need to use incremental analysis in order to do this, decide which is the best answer for this project. So in this case, I've been asked to calculate. This problem asks us to calculate net present value and internal rate of return, and the required return is 10%. So for the net present value at 10%, in the Gibson case, I have 587. And in the Sam Still case, I have 619. Because we know net present value is the right way to do things, those will always get you the right answer. We know that Sam Still is the best project. So let's go ahead and calculate internal rate of return. So in this case, I now is an unknown, and we set it equal to 0, and we solve for I star, and we get it at 14.35%, which is greater than 10%. So we know Gibson is a good investment on its own. And then the internal rate of return for the Sam Still is calculates out to 13.07. And we know that is greater than 10%. So they're both good investments. So the question now is, which is better? And it's not as simple as just saying, well, Gibson's better because it has a higher internal rate of return. What we need to do is we need to calculate the incremental cash flows. So what we first do is we look at the lowest cost alternative, in this case the Gibson, and we see that it's greater than 10%. And then what we're going to do is do the net present value of the incremental. So what we're doing here is we're asking ourselves, if we invest an extra $5,000, which is the difference between this and this, and then we actually do this investment, how much more cash flow am I getting? And that's 2,900, which is 9,000 divided by 6,100, 2,900 in both years. So the question then now becomes, what is the internal rate of return on this increment, which is 5,000 with $2,900 in 2 years? And the rate of return is 10.49, which is greater than 10%. Therefore, this increment is a good investment. So this extra $5,000 is a good investment. So we are going to invest in the Sam Still. And that's the correct way of doing that. And let's go back again and see that when we did this, we got a higher net present value for the Gibson, right? But we actually decided that Sam Still was a better investment. If we go back further and we look at the net present value, Sam Still is a better investment. So if we use incremental analysis correctly, we'll get the same answer as the net present value. If we use it incorrectly, we would have in this case gotten an incorrect answer, which is that Gibson is a better investment. And that's just important to remember, that we need to be doing this incremental analysis when we're comparing alternatives using internal rate of return. Now, the procedures that you need to go through are: make sure you're evaluating over equal lives, so make sure it's the same time period. Rank the projects by lowest to highest investment amount. So if you remember, that's what we did with the Gibson and the Sam Still. We first looked at the lowest investment amount. Calculate the internal rate of return of the lowest cost alternative. And if that internal rate of return is greater than the MARR, the required return, temporarily choose this alternative. If the IRR is less than MAR, reject this alternative and go to the next highest investment amount. Calculate incremental cash flows, calculate the internal rate of return on the incremental cash flows, and if the IRR, the increment, is greater than MAR, accept the next highest alternative and reject the lower cost alternative. If it's the other way around, accept the lower cost alternatives. And then repeat this until you've evaluated all alternatives. So it's a little bit confusing going through this procedure, but hopefully we'll have practice when you do a homework assignment. Now, this particular video looked at internal rate of return, which falls under the concept of investment analysis.